Hi, today we're going to talk about how to add fractions together. And so for our first example, we're going to start with 3/4 plus 1/4. Now, when we add fractions with the same denominator, I like to think of it 3/4 as we're going to take a candy bar and we're going to cut it into 4 equal pieces. So first I cut it in half, and then I cut each half in half again. And so if I eat 3 out of 4, that is 3/4. Now if I eat 1/4, same candy bar cut into 4 equal pieces, I'm only eating 1. So if you look at this, right, and that's 1/4 here, then if I take all of the eaten pieces together, I have 4 of the 4th pieces, right? So I have 4 out of 4. More specifically, if we have the same denominator, which is the 4 on the bottom, we keep one of those denominators and we add up the numerators. And so that gives us a 4 out of 4. And now we can simplify that. So 4 out of 4, we can think about the largest number that goes into 4, and the largest number that goes into 4 on the top and the bottom is 4. So if I divide the numerator and denominator by 4, I get 1 over 1, which is 1. And if you think about it, if I took this piece right here and instead I put it up here, you see that instead of the bottom piece and I took that top to the top, we get 1 whole candy bar. So I ate the 3 out of 4 little pieces and then the 1 more little piece that made 1 whole candy bar. So when you have the same denominator, it's relatively easy. You keep that same denominator, and then you want to add up those numerator terms until you get one number. Then you simplify, dividing the numerator and denominator by the largest number that goes into both to get a final answer of 1. Now for our second problem, notice unlike the first problem that we have different denominators. So if we had 2 candy bars that were the same size, the first one says cut your candy bar into 2 pieces and eat one of them. So that numerator is the amount you eat. The denominator is how many pieces you cut. So that is 1/2. But now for 3/5, I have to cut the same candy bar into 5 equal pieces. It's hard to make them even look equal. But anyway, use your imagination, and then I eat 3 of them. So unlike the last problem, notice in the last problem that all of my pieces were the same size. But in this case, I have these smaller pieces, and then I have this larger piece. And so we can't put them together. It's like apples and oranges. So what we need now is we need something called a least common denominator. LCD for short. That stands for least common denominator. And so we have 2 and 5. Now, basically, we are looking for the smallest number that can be divided evenly by 2 and 5. And so here's one way to find it very easily. I'm going to put a box around the larger number. Does 2 go evenly into 5? No, it does not. So now I add another 5 and I get a 10. Does 2 go into 10? Yes, it does. And so because I see that, 10 is my least common denominator. So again, the least common denominator is I want to think between 2 and 5, what is the smallest number that can be divided by 2 and 5? So I take my largest number, I say, does the smaller number go into it? No. So then I get the next multiple of that largest number, which was a 10. Does 2 go into 10? Yes, it does. That is my least common denominator. Now I go back to my problem and I write my new denominator for each. And now I'm going to focus on just this 2 and this 10. And I want to think about 2 times what is 10? And I know it's a 5. But since I did it to the bottom, I must do it to the top. That's kind of a rule here to kind of keep it all balanced. So 1 times 5 is 5. Now on the bottom here, I have 5 times something is 10. That number is a 2. Since I did it to the bottom, I'm going to do it to the top, and I get a 6. Now notice that when I did that, now I have that same denominator. So now if I cut my candy bar into 10 equal pieces, then I can kind of put those pieces together. So recall that when we have that same denominator, we keep one of the denominator and we add the numerator. And so when I do that, I get 11 over 10. And that is my final answer. Now for our third problem, notice again we have different denominators. Okay, and so we need to find the least common denominator. And so we'll have to figure out what that is. So I'm going to take my 3 and my 9, my 2 denominators. I'm going to put a box around the largest one. And I am going to say, does the smaller number go into the larger number? This time it does. Last time when we did it, 2 did not go into 5, so I had to get another multiple. But in this case, 3 goes directly into 9, and so 9 is the least common denominator. And so now I'm going to do the same thing as before, getting that same new denominator of 9, and then I'm going to look at this 3, and I want to make it look like a 9. So I multiply by 3 on the bottom, multiply by 3 on the top, and I get 3 out of 9. Now if I look at this other denominator on the right fraction, it looks just like the new denominator, no change. So really we're just multiplying by 1. Since I did it on the bottom, I'm doing it to the top. Notice that that second fraction did not change at all. And so that happens sometimes when the one denominator is the one that you want. Now, following our same procedure, we keep that same denominator of 9, add the numerators, and we get 8 out of 9. And so 8 ninths is 1/3 plus 5 ninths gives us 8 ninths. For our last problem now, we have 2 fractions with different denominators, and so we need to find our least common denominator just like before. So I take my 2 numbers, I put a box around the largest number. Now, does 8 go into 10? No, it does not. And so I get another multiple of 10. I add 10 on and I get a 20. Now, does 8 go into 20? No, it does not. And so I'm going to add on another 10. And so I get a 30. Now, does 8 go into 30? No, it does not. And so I add on a 10. So see how I just keep increasing that largest number. Does 8 go into 40? Yes, it does. And so here is our least common denominator of 40. So notice that the procedure is pretty much the same. We take that largest number, we say, does the smallest number go into it? If not, we keep taking multiples of the largest number, and then the smallest number, once it goes into the larger number, that's what you have for your new and improved denominator. And now we do the same process as before. We look at both denominators and we say the old denominator needs what to look like the new denominator? 8 times 5 is 40. Since I did it on the bottom, I have to do it on the top, and I get a 25. Same procedure on the right fraction. 10 times what is 40? Since I did it on the bottom, I have to do it on the top, and I get 7 times 4 is 28. Now in that numerator, since they're different, denominator is the same, we keep the denominator, add up the numerators, and so we get a 53 over 40, and that is our final answer. So 53 over 40 is 7 tenths plus 5 eighths, 5 eighths plus 7 tenths.